All right, Advent of Code 2021, day 16. I am looking at Packet Decoder. I've read through this one. This is by far the most complicated prompt of the year. Possibly the most complicated prompt I've ever had in Advent of Code. Um, there's a bit here where they explain hexadecimal. If you're not up to speed on hexadecimal, real short, one character is 4 bits. It's base 16. You go read more about it if you want, but basically the characters go 0 to 9 and A to F. You're going to get a single packet as an outermost layer, which itself contains many other packets. So it contains 0 to n packets. The first 3 bits. So I'm going to have to take this hexadecimal string, convert it to bits, and the first 3 bits are the packet version. The next 3 are a type ID. The type IDs are either 4, which means that the rest of the packet is literal value. And so there's a description here of how you take, let's see, so this is 1, 2, 3. So how you would take like this right here and convert it to the value 2021. It's done in a very strange way, but basically looking at, so, and I'll go to that when I get to breaking that up. And then here's the walkthrough of that. Well, I'll still do it now. So this packet right here has a 3-bit version number, then the 3-bit type, and the type in this case is 4, which is the type we know. And that basically just means the rest of the packet is look at this bit. If it's a 1, that means this is not the last little group. And then look at these next 4 bits. So 0, 1, 1, 1. And then this next 1 means, okay, this is not the next. So then 1, 1, 1, 0. Then this is a 0, so this is the last. And then you take 4 bits, 0, 1, 0, 1, and you're done. These extra trailing zeros are to throw away. And so with that, you combine those 3 numbers to get this, the 3 sets of 4 to get that, which is 2021 in decimal, and that's the value. None of that matters at the moment. I'm not going to use that in part 1, but that's there for later. Any packet ID not 4 is an operator packet that contains 1 or more sub packets within it. So by definition, every packet ends at a one of these type 4 packets, right? When there's only type 4 packets left, that's the depth of the packet. So let's see, the length, okay, so then there's a length ID type. There's 2 different ways that they can keep track of length. This is a really stupid system. It could be, if the length ID bit is 0, then there's a 15-bit number that represents the total length in bits of the sub packets contained in this packet. If the length is 1, then the next 11 bits are a number that represent the number of sub packets immediately contained by this packet. So that's going to be really a pain in the butt to process because sometimes you don't know how long the subpackets are, so you're going to have to just process the rest of the string. But okay, that's fine. Finally, after the length and the field, the subpackets appear. So subpackets. So skip down here for a little bit. We're going to come back to all this, I'm sure, but here's some examples. Lots of examples here of different strings and how many things they contain. But basically, I need to go through all of the packets in the transmission in the single line and sum up the version number, which is, so basically for each packet, the first 3 bits, and then sum that up and return for part 1. So this thing is going to be a monster to process, but let's see if we can figure it out. So we'll jump into Python. I've already got a little bit of a dummy thing here started. And from here, we're going to, so I'm going to read the line in. I'm just going to read it into one line because it's just one line. I want to convert it to binary, which actually not totally sure what the best way to do that is. So we will do some Googling. Python text to binary. See what they have to say. Here's Stack Overflow, always for the answer. That int, okay, that makes sense. So what I'm going to do here is, so we will say, we don't need to strip it because it won't matter. So we'll say, we'll do int, we'll convert this to an integer, base 16. So it's base 16, we'll convert it to an integer. And then we can just make this a string. We do that, colon B. I think that'll work. Print line. Python 3 day 16 example 1. Let's try that. Let's go back and check where was our example. The very first example was that. Did not mean to that. Let's say go in there. That looks like we read it incorrectly. Sweet. All right. So we will go now. We have our line now. That process is in our line. Happy with that. So now we need to loop over. Okay. I think I've been trying to figure out if this should be recursion. When I read the prompt and was thinking about it a little, I was trying to decide if this should be recursion or not. On the one hand, you have packets containing packets to an unknown depth. So recursion makes perfect sense, right? Because you can just process it. The challenge is that you don't know how long the rest of the packet is. So you're going to have to, in that sense, you're going to process it moving down the packet. And that's not really what recursion. If I always knew how long a packet was going to be, then that would be a very easy thing to do. But I still think I want to do recursion, so I think we're going to go with that. Def process will take bits. Okay, so what are we going to do? The first thing we need is the what do we call? The first 3 bits labeled v are the packet version. So ver equals bits, like that. And we want to make this an int, comma 2, and there's our ver. The next 3 are the type ID. Type equals int, bits, 3 to 6, comma 2. So now that'll make, I can't call it type. P type, because type is a Python known thing. Okay, so now here, if type equals 4, we're going to do all of this. So let's do that. Actually, we don't need to process that right now. If p type equals 4, return ver. Right? So that's all I'm going to do. I looked at the packet. It's got a version. I return it. I'm done. So we can even come down here and we can do print process line. If I call example 1, should get 6, which is the type. Example 1 just has the 1 packet, and there we go. So that's all we needed. So let's go to the non things here. So an operator packet contains immediately after the packet header. So the packet header was just the 2 values, right? Yeah, okay. So now, immediately after that, the next thing we need to do is look at the next bit. So we'll come up here. At this point, we know it's an operator, so we're going to say if bits 6 equals 0, then we need to get the length of the sub packets contained. Okay, so sublen equals bits 7 through, what's 15 plus 7 is 22. And again, we're going to make this int 2, like that. What are we going to do with the sub length? And so we're going to pass. We probably don't actually even care because, okay, well, let's do the else. Else, let's see, number of sub packets immediately contained by this packet. Okay, numpack equals int bits 7 through, and here we're only adding 11. 11 plus 7 is 28, comma 2. I don't think I did the math. 11 plus 7 is not 28, it's 18. There we go, that looks better. Okay, and then after the length, the sub packets appear. So I think what I'm going to do here, I think the strategy is going to be talking. I don't know if this makes sense yet. I'm talking out as I do it. I'm going to have um, process return the number of bits it used. And what that's going to allow me to do is allow me to step through, step through where I am, and figure out where the next packet starts. So I'll return 0 here because that doesn't matter because I'm just happy with that, right? Um, so here I'll do something where I'll say basically process, we'll say I equals, in this case, it's going to start at 22. We'll process bits 22 to the end, and that will get versum, comma, len, comma, L. So what I can do basically is say, while true, while true, packet, process the packets, and then in this case, what do? I process a packet. Oh, here we go. No, actually, I can say, well, I is less than, it's in this one, right? I've got, in this case, we're 0. I've got the number of bits that are going to come, right? So while that's less than sublang, I'll process I to the end. When it reaches the end of a packet, it will return and it'll tell me how long that packet was. So I do need to keep track of this length up here. This can't be a 0. I'll have to fix that. And then I can do I plus equals L. And then when L is equal to sublength, it'll break out and be done with that packet. That might work. Similarly here, let's try this. So here, now my bits numpack, I got that. So I can just do for I in numpack in range numpack. Versum equals 0. Versum plus equals v, like that. And so here, versum equals 0 for I in range numpacks, which we'll know. We will v comma L, v comma, we don't care about that, equals process bits. Maybe I do care about that. I equals, in this case, 18 bits I to the end. So we will do versum plus equals v, I plus equals L. So what I'm saying is, I'm going to pass in the whole rest of I'm leaving, instead of picking out a sub piece of the bit string and passing it in, I'm passing in the rest of the bit string and assuming that the processing will handle keeping track of how long, of how much of the string I use, and then it returns that value, and then I jump forward that much. That looks not bad. So then we can just come down here to the end, and either way, when I break out of here, I can return versum. That'll get me back up to previous ones. So I need to come up here and figure out, I do need to keep track of length here. So if p-type equals 4, I'm gonna have to figure out how long that is. So we're gonna have to process that. Let's go back up to where that was. We're just gonna do I equals, and we're now at 6. We'll be starting 6 bits into the string. We'll do while true if bit. Okay, no, we'll do res equals like that. And so we can say res plus equals bits sub I plus 1, because we're skipping the first bit is the flag or not, to I plus 5. So that'll give us those 4 bits. And we're going to try to build this res string. And then we can say if bits sub I is equal to 0, break. And then we'll do I plus equals 5. So we're going to start here. Our type is 4. We set I to 6, which is the first bit after the header. We then do a while true, and we're going to grab bits 7 through 8, 9, 10, 11, and attach them to our res string. And then if that flag bit was 0, we break, else we jump ahead 5 bits and we do it again until we get to a break. So then we want to return the total number of bits in the packet, which is return, in this case, the version is just going to be ver. Yep. And then the length is going to be I plus 5. Right? Because if we hit the 0, we still want to include the 5 bits after that. So I guess we could put this up here. Oops. And we then need to do bits I minus 5. This feels very sketchy, but it also feels like I think I've laid it out. Let's talk it through one more time here. So I get some set of bits. I know it starts with a header, so I'll get the version and the p-type. If the p-type is 4, it means I'm going to be done here. So I'm going to basically process through all these things and return how long I went as well as the version. If the p-type is not 4, it means I've run into some issue. So this is kind of effectively an else if, because this if statement always returns. So I don't need an else, but I can. So here I know the p-type is not 4. So then if the next bit is 0, then I'm going to get a length out of here. I'm going to set I equal to 22. I'm going to start a new sum of versions. Which should equal, so I don't even need ver sum. I can just start with, because I need the ver. I need this packet plus all its sub packets. So I can just make this ver that return ver, and then I'm also going to return. I'm going to check that I. That I might be wrong. Okay, so then I get down here and I'm going to pass the rest of the string into here, and it's going to return some length and some value. I'll increment my version total with the v, and I'll increment my I with the length. And if that I is now equal to, presumably, or make, I guess, greater than the sub length, it's going to break out of this loop. And then my I will be the full total length of what I processed. And yeah, I think this is looking promising. I fully expect it to break. Let's see. I feel like we jumped in complexity here a lot. Okay, so 6 and 21. Paxis is the first one. Here we go. Okay, we got some issues. Where are we having issues? Line 43. Okay, yeah, duh. Line 27. Process bits. Ooh, it can't be bits. Oh yeah, it can. Okay, bits I. Okay, so we can see our recursion here, and we're getting to a point where we're running a few recursives, and we're getting to a point where bits sub 3 does not is an empty string, and we still called it. Okay, let's go up here and see. What if we at the top here we print type 4 print. Okay, actually do type. I'm gonna call this type 0. I know it's not quite right because I'm just gonna call it type 0 and type 1 for the sake of type 1. Just for the sake of this labeling to figure out if we can help figure out what's going on a little bit. So we have type 0, type 0, type 0. That's can't be right. Oh, type 0, type 0. Type 0 can't be right. What is this example? Let's go back to it and figure out where I got this. Example 2 is what I was calling. So 38006F, that's this one. Okay. So I'm going to have 3 bits. I'm going to have a packet version 1. Great. Then I'm going to have a type ID 6, which means, okay, the bit labeled I is 0 for the length. That's what I got. Okay. And there's a 15-bit number. The 15-bit number is going to be that. The 11 bits labeled A contain the first a literal number. So that one shouldn't be. So let's see. Let's figure out. Let's walk this in. Let's do this in PDB. Python 3 minus m PDB. And we will break where? Break right at the top here on line 11. Minus C, break 11, minus C, C, go. Okay, so we're here. Bits is all of this stuff starting with 3 1s. Oh, we dropped. Aha. Okay, we're dropping leading zeros. That's good to know. How do I figure out what? Okay, I found an issue in how I'm reading in bits. Let's get out of here and explore that for a second. Print line exit. Let's just do that for now. Oops, not do that. See that? So that is there. That's my day 2 string. That's my string there. But what I should have is that, which is weird in multiple reasons. Python 3 int 16. So I'm gonna need to figure out some way to pad this. Maybe len that 14 times each of those is 4, so I should have a length of 56. Did I just copy that wrong? Okay, that looks, maybe I just had a copy error. Okay, that looks good except for the fact that I dropped the 2 leading zeros. So I need to figure out a better way to get this to include okay, we will do it hex line equals f.read now we can do line equals, we want len, can I put a variable here? Len of, could I say 56 here? Does that work? baby steps here. If I put 56 here, I get what I want. Oops, I need 0.56. Like that. Can I, if I say x equals 56, can I do that? No. Maybe this is just not the right way to go from an int to binary. Python int to binary with leading zeros. I could format it. I guess that's the answer, is to use binary.format. So if I do format, and then I do, what else am I going to do? If I do format at int into start easy 056b, I get the number I want. 0 x, oops, 0, and then my x is 56. So if I put, can I do this? Is this? Okay. This is ugly, but it's gonna work. So instead of doing an f string, we're gonna do the function format. We're gonna pass in this integer that we get from there, comma, and then we need to pass in a string that's gonna be like 056b. But the thing is, that string is not always going to be 56. It's going to be some expression that we will put here within an f string, and the expression is going to be len x line times 4. Invalid literal with base 16. Oh, I don't want to, because I can't read it twice. I will do hex line. Like that. I still got some extra. Did I get some extra? There's the result I'm looking for. I think I should go back double check that. There's still, now I put too many on the front. Oh, well, for one, I bet it's putting 4 extras on there from the new line. That looks good. That looks good. They're the same. In fact, yeah, okay. I think I've solved my problem there. So if that, just to make sure that makes sense, instead of reading this all in, I'm gonna read the hex line, get the hex, and figure out how long it is. And I need to strip to remove the new lines on the end. And then knowing that length, I can force with this format string to make sure that the length comes out what I want. So let's remove that. Type 0 followed by a type 4. And it returns a 7. Let's see what that looks like. Where is my example? The length, so it stops parsing, the packet stops. So in this case, I'm going to have a version of 1. And then I think I should have 2 packets. The first one is a type 0. And then A and B come out of that. A is a type 4, and B is a type 4. I should have 2 type 4s. I only see 1 type 4, so I'm not quite handling this correctly. Line 14, back into PDB. Okay, so this one, P-type, is 6, which is what I should see in the first one. Okay. So then I should step next. Bits is equal to 6 is equal to 0. That's going to be true. So I'm going to print type 0. Great. The sub length is 27. Okay. So then the next, we're going to set I equal 22. We're going to step I is less than, oh, that's interesting. That sub length should be 22 from this point, not 22. That's 22 more. That's the issue. Okay, does that make sense? So I'm now comparing against I against the sub length, but I started at 22. So what I need to do is say R equals sub length plus 22. Down here, that shouldn't matter. So let's try that again. There we go. Type 0, type 4, type 4. The length, I don't care. That's the length, and that's the value. So this should be 9. And what did I find? 1 plus 1, 2, 3. Plus that is 6. Plus that is 2. 1 plus 6 plus 2 is 9. 9. Sweet, it's working. Let's go to example 3 here and see if we can get this. See if this works. Maximum recursion depth. That seems like a problem. Also seems like not something I meant to. Lots of type 1s. Type 1, clearly not processing correctly. Gonna need to fix that. Let's see. Let's do the same thing we were doing up here. We will put our breakpoint again at this p-type checker. I'm sure, let's see. Okay, is it doing the same? Do I have some sort of similar error here? Let's check my logic again. Starting at 18, I jump forward. That seems reasonable. Let's check it. Actually, let's put the, yeah, okay. PDB. Okay, so the first one should be type 1, right, in this example. Let's do, what is hex string, hex, what was my hex line? E00D4. Yeah. Okay, let's just do a check here. What was my line? Is that print? How do we look? We're not quite, print line, new line, and then not sure why I put that extra single quote in there like that. So okay, they look good. That's just the example and my line. So my line's good. I'm happy with that. So ver is 7. Okay, that's what I got here. Perfect. The next one should be a type 3. So p type 3. Okay, happy with that. The I bit, where are we in there? No. Next that. Oh, type 1. Good, that's what we wanted. Oh, I don't want to set ver equals 0. Need to initialize that. That wouldn't be causing my problem, but that's good to know. Now I should grab the next 11 bits that say 3 subpackets. So we say next. Let's see, num pack equals 3, so I'm good with that. The next thing is I should have a packet A containing a literal number, a literal number, a literal number. So the next 3 should all be type 4. Let's see where we are. Okay, so we're going to step. Ooh, I see a problem. I do for I in range, and I'm overriding my I. And that's going to be a problem. I wonder if that was the whole problem. But 1 with 3 type 4s looks good. Total of 14. It's annoying they don't give me the answer here. So 7 plus, that's 2 is 8, 9. Plus 4 is 13. Plus 1 is 14. Oh, this is looking good. Okay, let's see. What's his example? I've got too many examples here. Cat 16 example 4, 8a, and the answer should be 16. Beautiful. The next one should be 12. Beautiful. The next one should be 23, 31. 23, 31. Let's get bold. 969. Boom. Go to part 2. Now that you have a structure of your transmission decoder, you can calculate the value of the expression it represents. Literal values represent a single number as described above. The remaining are more interesting. Oh, man. Okay, it's going to be a lot more processing. So packets with subtype 0 are sum packets. Their value is the sum of the packets below. I'm going to have to return more stuff. Packets with type I1 or product. Actually, I don't think this is going to be too hard. We're just going to have to write it's going to be a big if-else statement, but I think we're in okay shape. We're also going to have to start returning values. So we'll have to return a third thing, but that's okay. I wonder if these are the same examples as above. Equals 2 packets. That's interesting. Okay, so I guess we just need to start working on this. So the challenge here is, let's see. So I want to manage this so that I still need to process both these types, but I also now need to handle what do I do, more specifically for the different p types. I don't want to have this code have to show up 10 times, or 2 times however many p types there are. I don't think I need to. We can get rid of these prints. I don't think we need those anymore. Okay. We're going to need, for one, we're going to add another return value here. We're going to need to return the value here. And so that is going to be int res, comma, 2. So we're going to turn the string of bits into an integer and return it. That's great. So we need that. Now, when I come down here, we'll do res equals, we'll put res equals here. Now for each packet, when we're in a packet that has subpackets that are numbers, we need to know what the resulting numbers are. I think I can make the assumption that a packet's either going to contain some subpackets or some like operations, or it'll contain all numbers. I don't know that for sure, but well, no. Yeah, it's going to return, at the end of the day, it's going to return a series of numbers. Or I guess a number. A packet's going to return a number. Because it's either going to return, if it's type 4, it's going to return a number, or if it's type 6, or type something else, it's going to do an operation on a series of numbers. And even if one of those is an operation, it'll return a number anyway. So at the end of the day, it's always going to return a number. Okay, so what I can do is I can say res nums equals that. And here we'll do nums.append res. Cool. And so I can do the same thing here. This is actually going to be much cleaner, very clean, I think, cleaner than I was originally thinking. Nums.append res. So now, when I get down here, I need to just figure out what that number is going to be. So that's going to be based on the operation. Okay. So where is my, I need to go back to my thing here. So packets with type ID 0 are sum. They're sum the value of their subpackets. If they only have a single subpacket. Okay. So if p type equals 0, res equals sum nums elif p type type equals 1. We're just going to do the product. 1 math.prod nums here and import math, import sys. Not sure how I got into insert mode there. It's elif type equals 2. I need the minimum. Okay. Res equals min nums elif p type equals 3. I'm going to go ahead and guess equals max nums elif p type equals 4. Yep, that's max. Oh, I already 4 is the integer. I've already dealt with that. I need 5 is greater than. Come back to, let's go here. It's 5. If the value is 1, if the value of the first subpacket is greater than the value of the second subpacket. Otherwise, the value is 0. These packets always have exactly 2. Okay. Res equals int nums 0 greater than nums 1. So num 0 is 5 and num 0 is 4. That'll become true, which will become 1. Good. Less than is the same as 2yy p. Make that at 6. Make that there. Elif p type 7. Res equals, what are we doing here? Equals, if these packets always have exactly 2 packets. Okay. Int num 0 equals nums 1, else cert false. I think that'll work. Basically, I should never hit that, right? I should always have p type one of those things. Oh, it's 3 bits. I can't hit that. Well, we can leave it there. Let's see. Using these rules, you can work out the value of the outermost packet. So then we do return res here. Let's see what happens. Where's my examples? C200. Is that one of my examples? Ooh, that was a mistake. EX star. No. So I don't know if you're not familiar with the syntax. If you wrap a command inside of this angle bracket in parentheses like this, it basically takes this result, saves it in a temporary file, and then passes that file to as an argument. So that's what I did here. Okay, so by that result is 3. Look at that, we got a 3 at the end here. That's our result. Try another one. Oops, quote. 54. 54. Oh, we're feeling good here. Let's see. If this one is 7, we're going to skip right to the puzzle input. So we're going straight. Let's do it. 16 dash input. That is not a small number. And that's right. Awesome. That was hard, but kind of satisfying. So let's run through real quick what we got here. We're going to read so the reading was a little bit complicated. We needed to figure out how to take a hex line and convert it to bits. And it was the tricky part was making sure that we kept the correct number of leading zeros. Because by default that it won't put it there. And we did that by getting the length of the hex line, multiplying by 4, because that's how long we want our bit string to be. And then using this format string will give us 0 that length b, and then by passing that to format, it makes sure that that length is there with leading zeros. So that worked out well. We then process that line down into with this process function, which is a recursive function. It gets the version and the p-type. If the p-type is 4, it returns the version, the amount of space it used, which is not important, which becomes important when you're doing with subpackets, and the value. And then it, if the p-type is not 4, if it's some operation, it uses one of the two ways to read the value of all the subpackets. And if those subpackets are command packets, it processes those down to a value as well. And then, once it's got the list of all the numbers, it can, based on the p-type, reduce that to a single number, which is how you return the single result. So really cool, good use of recursion there. Relatively fast. So I really like this problem. This was a really fun problem. So hopefully you get a chance to try it and play with it. If you're new to this kind of stuff, like, play with this. Like, use PDB the way I do, and like go in and walk through and see how things are working. Maybe I should do a video someday on just how do you basic PDB knowledge. We'll see if that'd be interesting. Leave me a comment. But yeah, that's gonna be it for today. Thank you so much, and I will talk to you next time. Okay, I'm back for one last little thing, just because I like all my scripts to look the same. I am gonna do, let's see, I don't need length at all, and res equals process line. And instead of printing those out, I can just do print part 1 ver print part 2 res. This is just tickling my OCD needs, and that looks better. So with that, I'm out. Thank you so much, and talk to you next time.